As you can see here, we recorded the data that we used the calculator to produce into the table, the mean, the max, the min, range, absolute uncertainty, percent uncertainty, upper limit, lower limit, standard deviation, data error, upper limit, lower limit, and percent data error. And that takes us down to question 18. What is the minimum amount of data necessary to perform these calculations? Well, this is simply put, the limiting factor we have here is standard deviation, and we need a minimum of 5 data points to perform these calculations. So I might write 5 are necessary to compute the standard deviation. Briefly explain the meaning of data error. Data error is an uncertainty derived from taking multiple trials. To quantify the random error in the measurements. It is equal to twice the standard deviation. That's what the data error is. It comes from taking lots of trials and quantifying the spread in the data through the standard deviation. And we set that at 2 standard deviations, which is 95% confidence. So number 20, label any and all units that are missing from the table. Now it turns out that everything needs to have a unit. And up in the top, we've given information about the trial number. We've given units here. But up here, we've got plus or minus 0.05 and 0.10. We should have centimeters written there as well. We should have done that initially. Although it might be implied with the centimeters, we'll have it added just in case. Now the mean is 2.44. 2.44 what? Well, centimeters. And the same thing is true of the max and the min and the range and the absolute uncertainty. Percent uncertainty has units of percent. But the upper limit, 2.46, is centimeters. Lower limit, centimeters. Standard deviation is 0.01 centimeters. Data error is 0.02 centimeters. And similarly, these are centimeters. And the percent data error would be percent. So 21, state scientifically the full length of the object reflected in the table. Well, we'll start out with the mean, which is 2.44. 2.44. And then we have our uncertainty, which we will use as the data error, plus or minus 0.02 centimeters. That is the length. It's 2.44, and we are 95% sure it's plus or minus 0.02 centimeters. The next question is to compute and record the running mean of the data. Now the running mean of the data is a little bit tough to do. It's labor intensive with the graphing calculator, a little bit easier with a spreadsheet. So we're going to go to the graphing calculator to do this, and I'll show you some shortcuts. So in this next section, we're going to compute the running mean of this data set on the quiz. I'm going to show you some shortcuts to save time. It can be a lengthy process. So we start out with 2.44. And we want parentheses in front of that, and that's important. 2.44 plus 2.43 divided by 2. So we get a seemingly nonsensical answer, and that's because we forgot the second parenthesis. So we'll do a second entry, and we will back up here, and we will insert a parenthesis, and now we hit enter, and that's what we would expect, 2.435. So I write that to the hundredths place, 2.44. And now I want to do the next one. And so this is where the shortcut comes in. If I do second entry, now all I need to do is insert the third number. So second insert, third number is 2.45. And I forgot my plus. That's okay. Second insert plus. And now we need to change the divided by 2 to divided by 3. And we hit enter, and we get 2.44 even. And now we do another, and now we're going to, we have another 2.44, which we could add. We could do as an addition, or we could make it multiplied by 2. So we insert times 2. And now we have 4 things we're dividing by. And we hit enter, and not surprisingly, we get 2.44 again. And now we do that one more time, second entry, and the last number is 2.46, which is brand new. This is going to become a 5, and we back up here, insert a plus 2.46, and enter. And we get 2.444, and that 4 does not cause rounding, so we are left with 2.44. So in the last section, we computed the running mean, which you can see here was 2.44 all the way. Sometimes it was spot on, and other times it was rounded, but to the level of precision of the device, it was 2.44 all the way. So that is our running mean. So that is computation of the running mean of the data. State the confidence interval of the data error. Well, that is 95%. That is because 2 times SX is 95% of the data. State the confidence interval of the standard deviation. That would be 68%. Now, very quickly, the concept here is that the data follows a distribution that is a normal or a bell curve, with the mean value here like so, x bar. And if we compute a certain distance up from the mean equal to 1 SX and 1 down from the mean, 1 SX, that data corresponds to 68% of all the data if it's a normal distribution. If we go a second distance, second standard deviation, that is SX and that is SX, then that distance now represents 95%. And we could continue going outward and outward with more standard deviations. But the next one is 99%, and then it gets even more specific. But 2 standard deviations constitutes 95% of the data. 1 standard deviation is 68%. Explain whether you believe that there is sufficient data to determine the length of the object. I would say that the answer is yes. There is sufficient data. as more trials were taken, the running mean remained the same. And the data error was less than 1%.